We're all excited about TinyML, aren't we? Because I've shown you that there are a large number of possibilities about what we can do. In fact, there are probably possibilities that I'm not even imagining that we're already thinking about. And that's what's exciting about TinyML. Now, technology is powerful and it can bring about a lot of change. It can bring about both good and bad change. So one of the key things that I want to make sure you learn as you go through this program is that you understand what it means to deploy machine learning out in the field and to do so in a responsible manner. And that's what responsible AI is all about. AI offers us great benefits, but at the same time, it introduces new risks and ethical challenges that we must be very conscious about. We cannot build AI into all these tiny little devices, scatter them about everywhere, thinking that only positive things are going to come about it. That would be rather naive. Think, for instance, that just by having a phone on you all day, and if you look at all the gyroscope data, that you can actually figure out a unique individual. How so? Because the way that you walk and I walk, there's a certain gait or a cadence or a rhythm to it. And if you track that data, which is what these devices are totally capable of doing today, then people would be able to identify precisely without ever asking your unique name or your ID or anything else. And that's just one dangerous example because that infringes on your privacy and security aspects. So I'm not trying to say this in order to scare you. Rather, I want to be able to help understand that there's a big opportunity here. And if you think about AI being everywhere, I mean, think about the new risks and ethical challenges proactively so that we can actually use that to uncover new opportunities. So that's what I'm going to convey through the rest of this lecture. As new technologies come about, they often tend to be disruptive. That's not always neutral. In other words, you cannot assume that there's going to be, there's not going to be any cause for damage. Why? Because AI can bring about changes in current practices and the way we do things today, because now machines are starting to do some of the things for us. They can influence human decisions. For instance, when my phone says, take a break and breathe, or for instance, when a sensor is picking up some kind of interesting pattern and the phone gives me a nudge to do something, it's influencing my behavior. Now imagine if all these sensors around us, how would we know that we are even being influenced as this is a gradual process and they are collectively sort of regulating our behavior. So consciously or unconsciously, we might be following susceptible to the technologies that we are building. And that's extremely crucial that we as engineers of these systems, we open our mind into looking at the technology a bit differently and more holistically. Now, just looking at these use cases, but also understanding the potential ramifications, the implications of these use cases. Let me tell you, for instance, there was a research investigation recently done that shows that 65% of Americans believe that companies often fail to anticipate how their products and services impact society, in some ways called unintended consequences. Most people are wigged out by this. I would like to think that any piece of a product or technology that I'm bringing into my house has been carefully thought about. And it's not so much that, I have a piece of technology and oops, it comes and says, oh, I didn't know that, sorry, mistake made and, damage control may happen, right? So there's a bit of fear, uncertainty, and doubt when you bring in these devices that are making decisions on our behalf, with or without our permission. So what does that mean? It basically means that we need to be responsible when we are building this AI technology. While AI can actually mean a good size market, responsible AI can mean that it actually increases marketability because now people feel safer rather than being worried about, hey, this piece of technology might do something dangerous that I don't know or understand. It might actually increase the product adoption through better customer confidence and awareness. People might actually want to buy that product because they feel safe with it. They actually trust the particular device. But you and I, as engineers, scientists, researchers, we need to be doing this proactively in order to convince the people out there that we have done our job right. So this is not a new realization. Companies have been coming together, major organizations like Amazon, IBM, Facebook, DeepMind, Google, Microsoft, Everybody's been coming together in order to join forces in order to build partnership on, AI, where the key principle is to understand what are the risks are proactively, and then be able to build intelligent products that are safe for all of us, so that we can all benefit and society as a whole can benefit from this technology. So when you go over to work for them and build the next TinyML product, they're going to expect that you have learned the value of these responsible system deployments. I want to talk about these things from the perspective of three important use cases or deployment scenarios that we're going to see, with TinyML. We're going to understand, obviously, the technology benefit throughout this course, but then we're also going to see the cons of deploying TinyML so that you and I can proactively design these systems where we can adopt TinyML in a much more robust and safe manner. Specifically, if you look at industry, for instance, there are a lot of benefits of having TinyML deployed in industry because it reduces downtime for repairs. How so? Well, there are things like anomaly detection mechanisms that we will learn about where, for instance, by detecting sounds or behavioral patterns of a machine, that if something could go wrong, these machines give us little hints and clues in the vibrations. So they normally go like, woo, and when they have some sort of hints or clues where things are starting to break down, like, woo, then these sounds that they're emitting, that's exactly, I'm trying to replicate some of these sounds so you actually get an idea that before things completely break down, before they come to that endpoint, TinyML can actually detect these. They can figure out, the pump is actually going to break down in a couple of days. And so by knowing this proactively, we go ahead and get someone out there to replace it. The other consequence could be that, okay, well, the machine breaks down, and then somebody picks up the phone and says, hey, the machine is broken down. Would you fix it, please? And all this time, the entire manufacturing pipeline, the entire floor has to be shut down, waiting for this one particular product to be repaired. Instead, if someone proactively knew that it had to be repaired, they could go ahead and fix it, and the downtime would be much shorter. So you can improve efficiency of production operations. And it's also much more cost effective. Why? Because you're not suffering from a long downtime. Your downtime shrinks, which means that you're staying much more productive, and that looks great. But what about the downsides? The pitfall could be, well, how accurate are your predictions of the system that the system is actually going to fail? What happens if a jet engine that's going to fail, that costs millions and millions of dollars, and are you just going to arbitrarily go and replace it because your jet engine sensors seem to indicate something's wrong? Well, if so, then you have to worry about the accuracy. What about explainability? Who's responsible if it's a false alarm? Is the operator responsible? Or the machine learning smarts that we package together, is that responsible? And how do we hold an algorithm responsible over there? And overall, having this sort of predictive maintenance thing, how is it going to affect the workforce? For instance, are people going to lose their jobs? And is it necessarily a good thing for society? Or are we actually going to create new jobs in the service industry? And so these are the kinds of questions that we need to think about in industry, for instance. Now, let's talk about the environment. I gave you the example of elephant edge, where the goal is to save these elephants from extinction. Well, what are the benefits of having TinyML with smart collars around them? Well, you get to see very detailed insights, right? Often, when you want to learn something about these creatures that are out in the wild, it's like finding a needle in a haystack. It's a rare event. Okay, well, if you have TinyML going on around with these animals, well, you're going to get very precise, detailed insights. There's less wasted data because it's not like you're collecting all this data, writing it all into log books, and then analyzing it manually while something may have already changed in that environment. So there's a long lead time before you figure out anything and go back if we did not have ML at the edge. Well, with TinyML, we're talking about real-time responses. So you actually waste less data, and it's also more cost-effective because you don't need someone constantly walking behind the elephants in order to figure out what's going on with them. You could effectively be deploying these scholars out in the field, and then the humans are safe and they don't need to be venturing out in dangerous places. And you can also overcome the limitations of human labor just because the capability that the humans have in terms of going out and working year round in the forest is quite limited. So there are a lot of perks in doing this in the environment, out in the wild. But what are the downsides? Is the data that we are getting actually reliable? Are you sure? How sure are you about the data that you're collecting? We will look into this closely later in the fundamentals of TinyML course, where we are investigating how good is the data. Because with machine learning, the notion of influencing patterns from data that you're looking at is a stochastic thing. There's no guarantee that it's absolutely right or absolutely wrong. So how can you be 100% reliable? Are you sure the question you're asking, that the data that the machine learning algorithms are producing is actually correct? Who has access to that data? Well, if you're not careful about securing the data, someone illegal might actually get the data. Worse, imagine if you're trying to avoid the high-risk conditions that we talked about previously, where we don't want to get these animals into some dangerous poaching areas, right? What happens if the data that is getting collected and they reach the poachers themselves? Well, they get a lot smarter. And this would not be helping us while we are deploying those technologies. So we got to think about the security implications over here. And finally, let's talk about humans and how TinyML has great effect on us. Well, TinyML makes things more accessible. There are many people who are suffering from disabilities who can't touch or type and do tactile things, many of which you and I might take for granted. Well, if TinyML, for instance, is all about speech, so when you say, okay, Google, or hey, Siri, the machines wake up, they respond, you can interact with them, you don't need to touch anything. That's great. And that makes it much more accessible for everybody. Everybody should have access to the technology. And then it also makes the design of these products more intuitive, and because they are context aware. And effectively, that would streamline our design. And we would end up with much smoother and safer user experience. The bottom line is, if TinyML is great, machines around us would be that we are supplementing and working for us. We would rather us trying to understand how to work with the machine. We would have a much more natural way of working with the machine. So what are the downsides now in this case? Well, you've got to worry about is this going to work? Is this technology going to work uniformly across all different kinds of populations? One of the big issues that you'll find in machine learning that we will touch upon quite a bit is actually in diversity issues. Machine learning models rely on data. So if you're not getting data from different countries, for different races, different genders, then what are we going to do? Well, because the data is not there, then these algorithms are not going to learn on that data. And if they don't see it, they don't know it. And so what you don't know is what you don't know. And that's going to become a serious problem, especially if you're using machine learning to make intelligent decisions about you. Like, should this person be given a loan? What kind of credit rating is expected from this person? Or how much of a credit score will allow this person to take a loan? And we've seen in history that, this has not always been very fair. And so does this also threaten users' privacy, right? That's another big question. And that is, if TinyML is always on, what is it learning about us? What is it learning all the time, right? What if something is being captured and you don't want it to be captured, but the machine thinks it's doing good, trying to help you. But if someone gets into that data, then you've got a serious problem. So how do you protect that user's data? It might all seem like simple questions, but they're actually fundamentally deep. And they need serious technical chops in order to be able to solve them. And I'm talking about these things with you because they're extremely important. The consequence of not being careful can be disastrous. Why do I say this? Well, here are just some high-level examples of things that I want you to find on the web. For example, Microsoft's disastrous Tay experiment shows the hidden dangers of AI. This was a chatbot that was trained on data and interacted on Twitter with shocking conversations. You should go and check it out. Microsoft's disastrous Tay experiment. I'm not going to say what it is, but I want you to go and do your homework and look it up, actually. There was a microphone, for example, that was hidden in Nest. And I shouldn't say hidden, rather Google said that it was there for future proofing of the device. But no one mentioned that in the manuals, that it was there, that there was a microphone inside the Nest device. So that raised a big question about, hey, are they actually listening to us? They never told us there's a microphone in there. So this leads to a trust issue, which really can backfire on the organization. And your product basically falls apart because so you need to be careful about how these products are actually deployed. The algorithms can also be, unfortunately, rather discriminative because the data that they're seeing, if the data that's going to be biased, then they're actually going to be biased based on what they've been taught. It's no different than you and me learning from a textbook. And because if we only get one viewpoint, then that's all we have learned. And so we need to have a balanced portfolio and therefore balanced data set, so that the way the data the inferencing is done across the population is in a much more fair and equitable manner. And then finally, today, we also largely see, when we see these problems, we put it on like a Band-Aid on top of them. And so we say like, okay, great, we fixed that one problem. Not a problem. Okay, done, solved. But this is not how we can go about it, especially when we're going about deploying TinyML into billions of devices that are around us. There's going to be a lot of mistakes that we're going to be making over here. So we have to basically think of a different way to address these. So what's the point here? The point is that we need to be proactive and think about these things proactively, rather than viewing ethics as imposing constraints on an organization's ability to maximize shareholder returns. Let's consider how incorporating ethical principles proactively as design criteria for AI can result in innovative products, which can improve the well-being, reduce inequalities, and help individuals better achieve their goals. We need human-centered AI or human-centered machine learning. When we are developing these algorithms, how should we be thinking about the development of the algorithm so that we are conscious about the potential uses and issues that we might run into? And once we throw these devices out in the field, what are they, when they're operating out there, how do we consciously think about protecting the data that they're sensing? And what do we do with the mechanisms that need to be in place before they're put out there? So design, development, and deployment, these are the three critical stages. Each one of these which we will actually be going into more detail throughout this course. The core nugget of them is that we want to be able to keep human values in the loop at all stages of developing machine learning algorithms in these systems. So we will be talking about design, development, and deployment in each of these courses in part 1, 2, and part 3. In part 1, we're going to be centered around when we design the machine learning models. What are the things that we need to be thinking about? What are the characteristics of the data, for instance? And second, when we are starting to train these models for very specific tasks as we develop them, what are the nuances that you need to be worried about so that you're making sure you're teaching them the right things? Third is when you deploy them. You need to be careful about exactly what it means to put them out in the field and be responsible for the kind of data and how the data is secured and so forth. We'll be touching about all these things over here. So in the design stage, we need to ask the question, what am I building? Who am I building it for? And what are the consequences if it fails? This is a philosophically important issue, but this is also takes into account the safety aspects, the life critical aspects, if these decisions that are being made by the machines can actually adversely affect our health or our welfare. In the development stage, what is the data? Is the data set biased? How is this model going to react? Is it going to be fair to everybody? And in the deployment stage, when I put this out there, is the model going to drift if the data is kind of shifting? If the characteristics of your ecosystem are changing? Is it actually going to adjust to it? Or is it just going to keep going on doing the same thing that it was taught to initially, but now the situation has changed? Then how do you deal with security, which is a very big critical piece? And how do you preserve the user's privacy? We'll be walking through these questions through each part of this course. And I think having the sense of understanding and a framework for thinking through these ethical issues is going to make you a much better engineer.